Today we're going to be demonstrating the oxygen flow from the oxygen tanks through a rebreathing system. We're going to start with the oxygen supply tanks that are located in the radiography suite. From there, they go up through the wires and the cables through the ceiling to this oxygen reducing valve. The oxygen tanks start at 2000 psi. The reducing valve decreases it to 50 psi, a much safer pressure. From there, the oxygen will make its way to our oxygen drop lines in the ceilings, which we have multiple stations throughout the clinic that have these oxygen drop lines. We will connect the adapter from our machine by connecting it and turning it, and you'll hear as it's connecting, you'll hear the oxygen rushing in. When it stops and it's tight, you know you have a good seal. From there, you're going to follow, the oxygen is going to go through this hose right here towards our flow meter. So this is our flow meter right here, okay? And this is our oxygen flush valve. The oxygen is going to come from the oxygen hose, and it's going to go one of two ways. It's either going to make its way to the oxygen flush valve. When you push the button, it flushes the oxygen in, or it's going to come through this hose and up to the flow meter and into our flow meter when we turn that on. Before we get to the flow meter, I'd like to point out the oxygen flush valve. Please note that when you push that button, the oxygen flows in at a rate of 75 liters per minute. It is very fast. Because of this, you are not to be using it on a live patient. To do this could potentially kill your patient. What you will use it for is for leak testing and potential anesthetic emergencies. So if you have a patient that has an anesthetic emergency, as a cardiac arrest, you would remove the circuit from your patient, plug the end of the circuit, use the oxygen flush valve to remove any residual isoflurane within your circuit, and empty it to come out your scavenge. And then you have 100% oxygen going to your patient that's going through the emergency. The reason you do this is because the oxygen flush valve completely bypasses the vaporizer. So when you push that, it does not take any isoflurane to your patient. It just takes 100% oxygen. All right, so if you're going to be using your flow meter, your oxygen is going to come in here. And to turn it on, you turn it counterclockwise, and you'll note that there's a little ball that will move and let you know where your oxygen settings are at. Right now, I have it at 1 liter per minute. Note the graduations on your flow meter because every flow meter will be a little bit different. Some will go up by mils, some will go up by liters, so you do need to be aware of the graduations and the scale on your flow meter. If your flow meter has a ball, you will read the flow meter at the center of the ball. Some machines will have an arrowhead. With the arrowhead, which I apologize, I do not have an example of at this time. If you do have a flow meter with that, you'll read the flow meter at the flat part at the top of the arrowhead. With the flow meter on, the oxygen is going to now come up here and then come out this hose. You'll see it can go a few places. So it's, again, another tube to take it to the oxygen flush if needed. And then there is this hose here that will take it to your vaporizer inlet. So if you look here, it actually says at the top, vaporizer inlet. Okay, from there, the oxygen is going to come into your vaporizer and pick up whatever percentage of isoflurane you have it set at. Right now we have it set to off, so if I had the oxygen on, it would not pick up any isoflurane. If I had it turned on, which I have the oxygen off right now, so it is safe, but if I was to turn the vaporizer on, push this button, turn the dial, set it at my percent, it would then start to pick up 1% isoflurane. Okay, there's a little lock there to keep that safe. From there, it will come out the vaporizer to this vaporizer outlet. So if you look here, there is a sign that says outlet. Now, these adapters actually do come off, and there is a safety mechanism with them. They are different sizes, so you cannot put the inlet adapter onto the outlet side. It just will not fit, and vice versa. The outlet one does not fit on the inlet, so you cannot put the incorrect adapter on the vaporizer. And you just push them in with a little bit of a snug fit, just like that. All right, so from the vaporizer outlet, we are now coming and you have your fresh gas flow. So this is your oxygen and your isoflurane. You will notice your fresh gas flow come from this hose and come right up to this tube here. This tube here is your inspiration. It leads up here to your inspiration flutter valve. What that means is these are unidirectional valves, so they will only open when your patient inspires, and it prevents backflow of oxygen and isoflurane. From the unidirectional valve, the patient breathes in, this flutter valve will lift up. I'll demonstrate to you if you watch right here. Okay, you can see those flutter valves move. It will then, the oxygen will come through the inspiratory limb of your rebreathing circuit, and it will come out the Y piece, and this is the piece that is attached to your endotracheal tube in your patient. So then it will go to your patient's lungs. Your patient will inhale, take in the oxygen and the isoflurane. They will exhale, and the exhaled breath will come out the exhalation limb of the rebreathing circuit. Now, people wonder why the exhaled breath goes down this expiration limb, and the reason is that the gas takes the path of least resistance. This inspired limb already has constant oxygen flowing into your circuit and your patient. So the exhaled breath has to push against this, so it won't go up here if your oxygen rate is high enough at the proper rate calculated for your patient. When they exhale, it will take the path of least resistance and it will go through this limb now to our other unidirectional valve, and it's our expiration unidirectional valve or flutter valve, and as the patient exhales, it will lift just like this with each exhaled breath. From there are a few ways that the exhaled gases can go. So we have 3 different options. Some of the gas will go through this tube here and to our reservoir bag, along with fresh gas and oxygen as well from our system. Some of the gas will come out here and go out our scavenge, so we'll always have our pop-off open, and the rest of the gas will come out the scavenge hose. And some of the gas will be going through here to the CO2 canister, where it will absorb any exhaled CO2 and leave any exhaled isoflurane or oxygen to be going back to the patient. So what happens is it will come out this tube, back up to the patient's inspiratory unidirectional valve, and any of the oxygen and isoflurane that wasn't used comes back to this limb and it goes back to the patient. So it's like a circle. And that's why it's very important to always know if your CO2 canister is exhausted or not, because if it is exhausted, it will not absorb the end tidal CO2 and your patient will rebreathe the carbon dioxide, which you do not want and can be detrimental to your patient. That is it for a rebreathing O2 flow system, and next will be the non-rebreathing system.